Hello, we are going to work today on section 6.2, where we're going to look at operations on our new algebraic fractions or rational expressions. So we'll be looking at how to multiply, divide, add, and subtract these things. First of all, once again, I want to make an analogy to just regular numerical fractions because there's a lot of similarities between what we do there and what we need to do here. If you remember, when you're going to multiply fractions, what you usually would do in a case like this is look for ways to reduce to make things smaller before you actually multiply. For example, the 5 and the 25, you would probably divide those both by 5, making that a 1 and that a 5. And then the 12 and the 8, you would probably divide those both by 4, making that a 3 and that a 2. And once everything is reduced as much as possible, then you just multiply straight across. 1 times 3 is 3, 2 times 5 is 10. We'll be using a very similar technique in our algebraic fractions. In order to see where we can reduce, we'll need to have factored forms. But once we have those factored forms, we'll again try to reduce as much as we can before we do our actual multiplication. What about dividing fractions? We divide fractions by multiplying by the reciprocal. So we keep our first fraction the way it is, and then we invert our second fraction. Once again, we'll be following that exact same strategy with our algebraic fractions. We'll change them to multiplication by the reciprocal. Once we do that, we have the same reducing strategy as we did before. I could reduce these by 7, and the 20 and 15, I could reduce those by 5. Giving me a final answer of 8/9. So watch for those same strategies to occur with our algebraic fractions. All right, so in A, we already have multiplication, so we don't need to do any reciprocals. And so I'm going to start out by saying let's make sure we have all factored forms so we can see where it might be possible to reduce. So the 20x to the 6th, I'm just going to leave that alone for now. But in the denominator here, I could factor out a 7. That'll be 7 times x minus 2. In the second fraction, I can factor out a 2 from the numerator. So 2 times x minus 2. And then I'm going to leave that 50x squared the way it is in the denominator. All right, let's take a look at what we can do now. Certainly, I can take x minus 2 divided by x minus 2. That's just 1. And the 20 and the 50, I could divide those both by 10, right? So dividing by 10 would make that a 2. Divided by 10, then make that a 5. One more thing I could do. The x to the 6th and the x squared, I know that to divide those, I should just subtract the exponents. So I'm going to go ahead and divide them and make that an x to the 4th. Okay. So that's that reduce as much as possible before you actually multiply things out. All right, so let's see what we've got left. 2 times 2 times 1 would be a 4, and then I have that x to the 4th. And in the bottom, the only thing I have left here is 7 times 5, or 35. All right, let's try a few more. In B, I do have division, so I am going to start that one out by changing that to multiplication by the reciprocal. So first fraction stays the way it was. And then I'm going to change to multiply by, and then I invert the second fraction. All right, I now need all factored forms. Remember, I'm never allowed to reduce until I have my factored forms. So let's do that. Looks like I want to factor a 3 out of the numerator, which will leave me 2x plus 5. In the denominator, that's a difference of perfect squares. So 9 would be 3 times 3, and the minus x squared would be a plus x minus x. All right, second fraction, the numerator, I'm going to factor out an x. And whoops, looks like I made a typo, although it wasn't typing, it was writing. That was a 4x squared, not a 4x to the fourth. Let me fix that. Nonetheless, the denominator is going to take just a little bit of work because it's not a coefficient of 1. It's a trinomial. I will need sum and product, but it's going to be the extended version. So I'm going to just borrow a little space over here. Kind of do that off to the side. Let's see, I would need a sum of 4. And my product here is going to be negative 60. So I'm thinking 6 and 10, and I'll put the negative on my 6. So I'm going to rewrite this as 4x squared minus 6x plus 10x minus 15. First group, I can factor out a 2x. Gives me 2x minus 3. Plus, in the second group, I can factor out a 5. Also gives me 2x minus 3. So I'm going to get 2x minus 3 times 2x plus 5. And all of that was done just to get what goes in the denominator of that second fraction. All right, so let's see what we've got here. 2x plus 5 divided by 2x plus 5 is just 1. I don't actually have any other factors that match exactly, but you remember this one from our discussion in the last section? I have subtraction, but the order of the terms is backwards, right? I know I can divide those out, but they don't divide to 1. They divide to negative 1. All right, so what I have left on top, 3 times 1 times negative 1. So negative 3 times that x right there. And on the bottom, I have 3 plus x. And let's talk about that for just a minute. In this case, 3 plus x, if I prefer to write that in descending order, I can just reverse that and write x plus 3, right? Changing the order in addition is perfectly possible. It's just subtraction where it's a little special. All right, and then we got the 2x minus 3 from over here. So that would be the division completed with the answers simplified. All right, I have just a couple more of those on the next page before we turn to other operations. In C, it's already multiplication, so I'm just going to go ahead and start factoring everything. And let's see, I'm probably going to need some space to do a little factoring, so let me do that over here. My x cubed minus 27. It's a difference of cubes, so I'm going to think of it as 2x to the third power, subtract 3 to the third power. So I have my u is 2x, and my v is 3. So I'm going to get 2x minus 3. And let's see, u squared would be 4x squared. When I multiply u times v, I'm going to get 6x plus v squared, which will be 9. So that's the numerator of the very first fraction. All right, in the denominator, I can factor out an x, and that's going to give me 6 minus x times numerator in my second fraction, nothing I can really do with that. It's just x minus 6. If you'd like to put parentheses around that, sometimes it helps people kind of see what's going on. It doesn't hurt anything, and it certainly can help. And then I've got my 4 terms, so I know that's going to have to be trying grouping. Let me, again, just do a little bit of work off to the side here. So I'm going to group my terms. I can factor an x squared out of the first group, which makes that 2x minus 3, and then a 5 out of the second group, which also gives me 2x minus 3. So I've got 2x minus 3 times x squared plus 5. And that is my second denominator over here. All right, so let's see what we've got going on. 2x minus 3 divided by 2x minus 3 is positive 1. X minus 6 and 6 minus x, I can divide those, but again, the subtraction in reverse order. When I divide them, I get negative 1. And I think that's all this time. So on top, I have negative 1 times all of this. Now that negative 1, this is one of those places where we have several options. We can just put the negative sign in front of the entire fraction if we want to, or we can distribute it through the top, or technically we can distribute it through the bottom, but that's pretty uncommon. I think I'm going to choose to distribute it through the top this time. So I'm going to take that negative sign and distribute it all the way through there, giving me negative 4x squared, negative 6x, and negative 9. And in the denominator, I have x times x squared plus 5. Very often when this happens, and I forgot to mention it in the last example, we actually leave our problem in factored form like that. Factored form is generally more useful than multiplied out form, and so typically when I have an answer like this, I don't multiply it out. Same thing here, I would probably not multiply that out. And you'll find that both when you do your homework, in my math lab and the worksheets, that factored form of the numerators and denominators is perfectly acceptable. All right, one more like this. I have one more division problem for us to look at. And the division is by something that's not in fractional form. You're going to want to go ahead and put that in fractional form by just putting 1 into the denominator. And now we can say that to divide, we're going to multiply by the reciprocal. All right, I need to get my factored forms, and these are all 3 trinomials, so they're all sum and product. But the good news is I've got my coefficients, my leading coefficients here are all 1s, so I'll be able to use some shortcuts this time. Let's see, in the numerator, I know that x squared has to be x times x, and I'm looking for a sum of negative 7 and a product of 6. So I'm thinking negative 1 and negative 6 would do that. In the denominator, again, it's just 1x squared, so I know my binomials will start with x and x. This time I'm looking for a sum of -3, product of -18. So what's that one? +3 and a -6. I do that. So my +3 and -6. And then 1 over, once again, a trinomial that's going to start with x times x. And this time I need a sum of -2 and a product of 1. So that has to be -1 and -1. All right, x minus 1 divided by x minus 1. That is 1. And x minus 6 divided by x minus 6, that's also 1. By the way, sometimes people think that you for some reason can't do that because those are in the same fraction. It's not necessary that they be sort of on that diagonal or in opposite fractions, as long as one factor is on top and the other factor is on the bottom. Perfectly fine to go ahead and do the division. So I just have 1 times 1 times 1, which is 1 on top. And again, I'm going to leave this in the factored form. The denominator is x plus 3 times x minus 1. All right, so that is multiplication and division. Mostly it's a lot of factoring, and then you just have to look for those places where you can divide out the common factors. Let's turn to addition and subtraction next. Once again, what we did to add or subtract numerical fractions is the same thing we're going to basically do to add and subtract these algebraic fractions. If we're lucky enough to be given a problem that already has a common denominator, then all I have to do is add or subtract the numerators. So 7 minus 4 would be 3. And then I keep that same common denominator for my answer. Once I have that done, of course, I would want to reduce my answer to lowest terms, which in this case would be 1/3. I'll use the exact same idea if I happen to be lucky enough to have a common denominator already. All I have to do is subtract the numerators. Now do be careful with these. Remember that when you are subtracting here, you are subtracting both terms, not just the first one. So I'm actually subtracting 2x and subtracting 3. It's up to you, but I will say that if you have a tendency to forget that, it doesn't hurt to take just a moment and change that to plus and then distribute the negative sign before you start combining. It goes a long way toward preventing mistakes, so I definitely recommend that if you have a tendency to forget about the minus sign getting distributed. Now I can say 3x minus 2x is 1x, and 1 minus 3 is -2. Now just like this last one, once you've subtracted, answers aren't guaranteed to be in lowest terms. Sometimes they can be reduced, right? So I need to ask myself, is that in lowest terms, or could I reduce that a bit? I won't know unless I look at the factored form of the denominator. So I'm going to do that next. This is a trinomial again, so I can do sum and product. It has to start with x times x. And I'd be looking at a sum of -6 and a product of 8. Thinking -2 and -4 would do that. And so indeed it wasn't in lowest terms. I can divide out the x minus 2's. X minus 2 divided by x minus 2 is 1. And my final simplified answer is then 1 over x minus 4. All right, so overall, As long as you already have a common denominator, these are relatively straightforward, right? Add or subtract the numerators, keep the common denominator, and then just check at the end to make sure your answer is in lowest terms. What if we don't have a common denominator to start with? Well, in that case, we need to get one. So again, let me just really quickly remind you of the technique for regular fractions, numerical ones, and then we'll go on and look at some of the algebraic fractions. If I'd like to add 5/6 plus 3/4, the first thing that I do is identify a common denominator. We often call it the lowest common denominator, or LCD. And in this case, both 6 and 4 would go evenly into 12. So 12 would be my LCD. You then create that common denominator in both of the original fractions. So I look at my 5/6 and I say, what's missing? What do I need to multiply by to get to that 12? Well, I need 2. And so I multiply by 2 over 2. Why is it so important to multiply both the top and the bottom by 2? Well, 2 over 2 is really just a form of the number 1, right? 2 over 2 is 1. And because I'm really just multiplying by a form of 1, I'm not changing the value of the number that I'm adding. That's really important. It's okay to change the appearance, but I can't change the value, or I've changed the problem. So that's going to give me 10/12. I'm adding 3/4. And again, I need to ask myself, what do I need to do to create that LCD? Well, to go from 4 to 12, I'd have to multiply by 3. And once again, I have to multiply by a form of 1. So I'm going to multiply by 3 over 3. And so I'm actually adding 9/12 to get an answer of 19/12 now that I have a common denominator. I know you all knew how to do that problem before, but I really wanted to kind of have you focus in on the idea that we always multiply by a form of 1 so that we don't change the value, and that our goal is to create that common denominator, because we're going to do that exact same idea as we do the same process with algebraic fractions. One last note. In algebra, we would always prefer an improper fraction like this rather than a mixed number. So don't change that to 1 7/12 either now or in the context of any algebra problem. You want to stick with your improper fraction. All right, well, let's look at a problem over here now that's got some variables in it. So it's an algebraic fraction. I'm looking at my denominators, and just like before, the first thing I need to do is figure out what the lowest common denominator, or LCD, is going to look like. For 5 and 3, it's definitely going to be 15. With the x's and y's, if I just take the highest power of each one, so for the x's, I'll take the x to the 4th, and for the y's, I'll take the y squared. Because I've taken the highest powers, I'll now be able to multiply to kind of fill in the missing pieces to create that LCD for both fractions. So let me go back to my 2 over 5x to the 4th y. I'm going to compare that to the LCD, and I'm going to say, I definitely need to multiply by 3 to get that 15. The x to the 4th is actually fine, but I need another y. So I'm going to multiply by 3y in order to create the LCD. Now I always have to multiply by a form of 1, so I better also multiply the 3y on top. 3y over 3y is just a fancy way of saying 1, right? So that first fraction becomes 6y over 15x to the 4th y squared. All right, my second fraction was 4 over 3xy squared. Again, compare what I have to the common denominator. I'm definitely going to have to multiply by a 5 to get the 15. I have x to the first, but I want x to the fourth. So I need an x to the third to get there. Y squared is already there, so I don't need to do anything with the y's. Make sure I'm multiplying by a form of 1. And my second fraction is now 20x cubed over 15x to the fourth y squared. Now that I have a common denominator, I can combine these into one fraction. Now the numerator doesn't have doesn't have like terms, so I can't actually add those terms, but I can put them together as one numerator over my common denominator. If there had been like terms there, I would have combined them, but in this case there weren't. All right, so let's try a couple more problems where we have to figure out a common denominator. This is really just a little review of all the steps that we've been talking about. All right, as I look at A here, these two denominators are really completely different. And so in a case like this, I'm just going to say that my LCD is just the product of both. X plus 3 times x minus 5. I take my first fraction, 6 over x plus 3, and comparing that to the LCD, what's missing is that x minus 5 factor. So I'm going to multiply by x minus 5. Again, top and bottom, because it has to be a form of 1. I kind of like to throw my parentheses in here at this stage as well. Otherwise I might forget them later. All right, so this time, let me go ahead and multiply that out. That would be 6x minus 30 over x plus 3 times x minus 5. Let's go back and work with the second fraction now. 2 over x minus 5. Again, I compare what I have to my LCD, and I'm missing the x plus 3 this time. So I'm going to multiply by that x plus 3 over x plus 3 to get the form of 1. And so that would be a 2x plus 6 on the top of that fraction now. Right, I have the common denominator, so it's okay for me to combine them now into one fraction. Adding here, I would have 8x minus 24 over the LCD. And by the way, it doesn't matter which order you choose to write the factors in. Either way is fine. I'll just do x plus 3 over x minus 5. I'd like to check that to see if it can be simplified. And in this case, I think the answer is it can't. If you just think through this with me for a moment, I could factor an 8 out here on the top, but when I do, I would have x minus 3. And that would not divide with the x plus 3. So since nothing's going to divide out, nothing's going to simplify, I won't bother factoring. I'll just go ahead and leave it like this. It wouldn't hurt if you left it like this. But generally speaking, if I can already see that I'm not going to be able to divide anything out, I usually don't bother with the factoring, and I usually just leave it like that. But either answer would be acceptable. All right, try another one here. So this time, my denominators are a bit more complicated. In fact, both of those denominators could be factored, right? It's always best to start with factored forms. Definitely helps you find the LCD a lot more easily. So I'm going to start here by saying this could be written as x times x minus 2. I'm going to leave myself some space over here to create my common denominator. Minus 1 over, let's see, x squared would be x times x. Trinomial is sum of negative 5, product of 6. Thinking negative 2, negative 3. All right, so what does our LCD look like in this case? Well, I definitely have to take the whole first denominator, x times x minus 2. But when I come over here, I've already incorporated the x minus 2, so I don't need to put another one in there. I've already got that. But I do have to include the x minus 3. So in a case like this, you just kind of build your denominator. Take the whole first one, and then just tack on any new factors found in the second one. All right, so clearly this one is missing the x minus 3. This one is only missing the x. So I'm going to have 4x minus 12 over x times x minus 2 times x minus 3. Subtract x over x, x minus 2, x minus 3. By the way, little pitfall here. Don't be tempted. Yes, you could divide out those x's if you wanted to, but you don't want to, right? You were just worked hard to create that common denominator. So don't ruin it now by canceling stuff out. Instead, we're going to say, got a common denominator, so I can combine these. 4x minus 1x would be 3x. Got this minus 12 here, all over the common denominator. As I look at this, again, I could factor a 3 out of here, but that would give me x minus 4, which isn't going to divide with anything in the denominator. So I think I'm just going to leave it like that. All right, I have a couple more of these, just give us a little chance to practice. I know sometimes it takes just a little bit to be comfortable with the adding and subtracting in particular. So let's see what we got here. I have x minus 2, trinomial again with a nice leading coefficient of 1, so that's x times x, and a sum of negative 2, product of 1. It's going to have to be negative 1 and negative 1. And again, I'm going to leave a little space in here to create my common denominator. Minus 4 over, and this one, the 3x squared minus 3, you could definitely factor out a 3, which gives you x squared minus 1. But that's now a difference of squares. So I'm going to say 3 times x squared is x times x. Negative 1 is plus 1 times minus 1. All right, so there's my factored denominators, and I'm ready to identify my LCD. Now, x minus 1 occurs twice in the same denominator.
So I do want to go ahead and include it twice in my LCD as well.
If you prefer, you could write that as x minus 1 squared, right? I then come over to the second denominator,
and 3 is new, so I'm going to include that. X plus 1 is new, so I'm going to include that. But x minus 1 is already represented, so I don't need to put another one in there. All right, comparing my first denominator to the LCD. I need a 3, and I need an x plus 1. Second denominator, comparing to the LCD, I'm missing one of the x minus 1's. All right, so what have I got here? This one might take just a little bit more algebra to actually get simplified, so let me at least get started. I'm going to write this first one as x minus 2 times 3x plus 3. And I'll actually do that multiplication in my next step. And I'm going to go ahead and make that x minus 1 squared now.
I'm actually going to do something else here that's going to help me out. Remember how we talked about subtracting? It's so easy to forget to distribute the negative.
I'm going to change that to plus, and I'm going to make that a negative 4 times that x minus 1.
And again, I'll distribute that in the next step.
Right, that is the x minus 1 squared again in the denominator. All right, so if I multiply this out, I'm going to get 3x squared plus 3x minus 6x minus 6. And if I multiply that out, I'm going to get negative 4x plus 4. And I can write all of that over my common denominator.
And then finally, I can go ahead and combine my like terms on the top.
I have 3x squared. Let's see, that would be 3x minus 10x, so negative 7x. And negative 6 plus 4 would be negative 2. Over my common denominator.
All right. Probably should check and make sure that doesn't factor.
Think I'm okay. I would need a sum of negative 7 and a product of negative 6. If I do 1 and 6, the problem is that if I make them both negative to get the negative 7, then the product is positive. So
I don't think I'm going to be able to do that.
I think this is done.
All right, I've got one more here. And once again, my denominators are not yet in factored form, so let's do that first.
That's my difference of squares. W times W and plus 5 times negative 5. And this one, if I factor out the W, I get 5 minus W.
As I look at this, I'm thinking, wow, those are actually different, but they're so similar, I really hate to have to include both of them in my common denominator. So I'm going to use sort of a similar trick as what we used before. We've seen that subtraction reversal before. I don't have anything I can actually divide out with the 5 minus W this time. But what I can do is I can multiply this
by negative 1. I know when I do that, that's going to turn that into a positive W and a minus 5,
and it'll match this really nicely.
Now again,
always multiply top and bottom by the same thing. You have to be multiplying by a form of 1. And let me do just that much. Top now 2 times negative 1 would be negative 2. And at the bottom I've got the w, and then I'm going to make that a positive w, which I'm going to write first, and then a negative 5. Taking the time to do that was really important because now my common denominator is going to be much nicer. I won't have to include both of these because now they both look alike. So for my LCD, I will have w plus 5 times w minus 5. This w also has to be included, but that w minus 5 is now already there. All right, I didn't leave myself a ton of room, but I think I could sneak this in. This first fraction is really only missing the w. So I'm going to multiply that one by w over w. This one is missing the w plus 5. And let's see, I'm going to go ahead and put parentheses here because I do have to distribute. I'll have w squared plus w. And I'll distribute there. Minus 2w minus 10. And I can now put that all as one fraction with my common denominator. So a tiny bit of simplifying on the top. W squared minus w minus 10. And keep that LCD. That does not factor, so I know I'm done. All right, so biggest thing with adding and subtracting, just always make sure you create that common denominator before you actually combine things and do the addition or subtraction. All right, we have one more topic, and it's kind of a combination of the other two. We're going to talk about simplifying what are called complex fractions. A complex fraction is just a large fraction that contains smaller fractions within it. Okay. There are two types. I kind of approach them differently. The first type is really just a glorified division problem. If I've got a fraction on the top, and this big fraction bar here, and then another fraction on the bottom, I can just treat that fraction bar as a division sign. And we already know how to do that, right? To divide, we multiply by the reciprocal. So I would just change this to x cubed plus 27 over 2x squared minus 11x plus 5. And I'm going to multiply by the reciprocal of the second fraction. Okay. So it looks different, but it's actually a problem you already know how to do. All right, well, let's go ahead and see what we can factor here, because that's what we'll need in order to simplify. I will make my space for factoring over here. The x cubed plus 27 is x cubed plus 3 cubed. So I'm going to do my sum of squares with a u equal x. Excuse me, my sum of cubes with a u equal x and a v equal 3. So I'll have x plus 3 times x squared minus 3x plus 9. All right, denominator, also unfortunately one that's going to take a little bit more work. Trinomial, but Leading coefficient's not 1.
So I'm thinking sum is negative 11. Product is 10. So I'm going to go with negative 1 and negative 10 there. So I've got 2x squared minus 1x minus 10x
Plus 5.
I can factor an x out of the first pair. So I've got 2x minus 1. And I do need to factor out a negative here. I can also take out a 5. And again, I get 2x minus 1. So I've got 2x minus 1 times x minus 5.
Phew, all right, you gotta keep going. Second fraction. Fortunately, I think the factoring on this one's a little nicer. The numerator over here, I think all I can do is factor out an x, which makes that 2x minus 1. And the denominator is a trinomial again, but with a leading coefficient of 1, I know it's going to start with x times x. And then I just need a sum of 9 and a product of 18. So 3 and 6. Okay, what can we divide out?
X plus 3 divided by x plus 3, positive 1. 2x minus 1 divided by 2x minus 1,
Also positive 1.
I think that's it. So on top I'm going to have just 1x times that trinomial. And on the bottom I'll have x minus 5 times x plus 6.
All right, I have a couple more like this, but these last two are really intended to remind you to really be careful where the parentheses are, where the large fraction bar is. Notice there's a lot of similarities between these two problems, but the parentheses are different, and that's really important.
Here the large fraction bar is right there. And so I'm going to think of that as a division sign. I have to think of this as x squared over 1, so that I can write it as multiplication by the reciprocal. So I'd have 4x over x minus 5 times 1 over x squared.
This time, thank goodness, there's no factoring to do. I think we got our fill of that in the last problem. But I can do one thing to reduce.
This x divided by x squared,
that would actually give me x to the negative first, or x to the first on the bottom, right? So
on the top I just have 4 times 1 or 4. And the bottom I have x times x minus 5, which again I'm just going to leave in factored form.
Compare that to C, where the parentheses are done differently.
This time this is my large fraction bar. And so I can think of this as 4x over 1 if I want to. And I'd have 4x over 1 multiplied by the reciprocal of the denominator, x squared over x minus 5.
Not only is there nothing to factor, but this time there's really nothing that divides out.
So I'm just going to go ahead and I might as well multiply that. That's easy, just 4x to the third. And 1 times x minus 5 is x minus 5.
So definitely very different answers to those two problems. All right, one other type of algebra or a complex fraction to finish out our section here. Sometimes our algebraic fractions have multiple small fractions. in either the numerator or the denominator, or even both. When that happens, here's my advice. This usually gets you to a simplified form fastest. Multiply the top and the bottom of the complex fraction by the LCD of all the fractions in the expression. So as I look at this, I see 1, 2, 3, 4, 5 little fractions within that complex fraction. I want to pick one LCD for all of them. Now, since these are all just powers of x, the LCD will be the largest power, x cubed in this case. So what I'm going to do is I'm going to multiply by x cubed over x cubed, the LCD, top and bottom. Again, notice that's just 1. I'm multiplying by a form of 1, which doesn't change the value. All right, in order to do that, I think it's going to help if I think of both of those x cubes as x cubed over 1s, because I'm now going to have to distribute that to all these small fractions. Okay. Depending on how comfortable you are, you may be able to do this next step in your head, but since you can't see inside my head, I'm going to write it out. If I multiply, this first fraction becomes 4x cubed over 1 times x, which is x. Subtract. Second fraction becomes 8x cubed over x squared. Plus. Third fraction is going to be 3x cubed over x cubed. Okay. Do the same thing in the denominator. We have to distribute here. So my first fraction becomes 2x cubed over x minus. Second fraction is 3x cubed over x squared. So I've just distributed to do the multiplication, top and bottom. All right, each of these fractions simplifies really nicely. Just subtracting my exponents, that's 4x squared. Subtract 8x to the first, plus 3. And in the denominator, 2x to the second, minus 3x to the first. If you get comfortable with this, you may actually be able to go straight from this step to that step and just kind of subtract the exponents in your head, and that's fine, but I wanted to make sure you saw the whole thing written out at least once. All right, I probably need to factor these. I'm not convinced yet, anyway, that this is not going to reduce, so let's go ahead and do a little factoring. That 4x squared minus 8x plus 3, trinomial, so I'm looking for sum and product. Sum negative 8, product 12. So negative 2 and negative 6 would do that. Let's see, I can factor out a 2x here, which makes that 2x minus 1. And I want to factor out a negative and a 3 there, which also gives me 2x minus 1. So I've got 2x minus 1 times 2x minus 3. Bottom, I can factor out an x, which makes that 2x minus 3. And it was a little bit of work, but it was worth it, right? Because this time we did get to reduce here. And my simplified answer is going to be
just 2x minus 1 over x.
Which is certainly a pretty major simplification from where we started from. All right, I have one more of these complex fractions where it's not just as simple as just do the division. Here I've got two smaller fractions within the larger one, but because I'm adding the 2 here and subtracting from the 4 there, I can't just say, hey, it's just a simple multiply by the reciprocal. So I'm going to use the same process. I'm going to say I have two smaller fractions, and their LCD would be x plus 1 times x minus 1. All right, I have to distribute that here. So I'm going to have 3 x plus 1, x minus 1 over x plus 1 plus 2x plus 1, x minus 1, and I don't really even need the one on the bottom there. In the denominator, I'll have 4x plus 1, x minus 1, subtract 5, x plus 1, x minus 1, over x minus 1. I can reduce a bit. I can divide out the x plus 1's here, and I can divide out the x minus 1's there. That's going to make this 3x minus 3 plus, let's see, that's really 2 times x squared minus 1, right? So I'm going to write it as 2x squared minus 2. Same idea here. That's really 4 times x squared minus 1. So I'm going to write it as 4x squared minus 4. And then I got to distribute the negative 5, so negative 5x minus 5. All right, get some descending order going here. 2x squared plus 3x minus 5 on top, and 4x squared minus 5x minus 9 on the bottom. Once again, I'm thinking I probably should check factoring here because I don't know whether that might reduce. So this one would require a sum of 3 and a product of negative 10. Let's see here. How about positive 5 and negative 2 on that one? Factoring out an x will make 2x plus 5, and factoring out a negative 1 will also make 2x plus 5. So 2x plus 5 times x minus 1 on the top. Denominator? It's going to need a sum of negative 5 and a product of negative 36. So I'm thinking negative 9 and 4 on that one. Factoring x out of the first one, it's going to give me 4x minus 9, plus just a 1 out of the second one also makes 4x minus 9. So I've got 4x minus 9 times x plus 1. And it looks like I did not get anything that actually reduces there. So I could have left it like this if I wanted to, but it was close, right? We almost did there with the x's. I just didn't quite get the same factor. I didn't know that until I went through the factoring process. So sometimes you might get stuck factoring a little bit more than you had hoped to, only to find out that nothing actually happens. By the way, that answer is fine, but the factored answer is also perfectly fine as well. All right, that brings us to the end of section 6.2.